Okay, Randall, are you back? Then I can start the lesson for today. Okay. So today we are going through another part of trigonometry. Okay, so we are talking about the addition and double angle formula. Okay, so what is addition formula? It deals with expressions like this. Something that looks like this, sine of something plus something. So some of you might think that this is just equal to sine A plus sine B, but this is not the case. So actually we have special expansions for this addition formula. Okay, so we have one addition formula for each of the three trigo ratios, which is sine, cosine, and tangent. And then for here, take note that this thing is opposite here also. So this means that when I have cosine A plus B, then here the sign will be negative. But if I have cosine A minus B, then here the sign will be positive. Okay, then for double angle formulas, similarly, it's talking about doubling your angle lah. So like sine 2A, something like this. So sine 2A is not the same thing as 2 of sine A. Again, we have a dedicated formula for that, called double angle formula. And then cosine is special because we have three different formula that we can use for the expansion. First one is cosine square A minus sine square A. Second one is 2 cosine square A minus 1. And then the third one is 1 minus 2 sine square A. So depending on the question, you have to choose which one is most appropriate. Okay, so that's all of the content for today. Any questions so far? Oh, one thing to know about this double angle formula is that, right, over here, this angle will always be double of this angle. So if, for example, I have sine of A, I also can expand it like this. Because here, this angle is double of here. So that's how double angle formula works. So far, everything is okay? Have you all seen these formulas before? Oh yeah, all these formulas are in your formula sheet. For your, like during the exam, they will give you this formula sheet. And all these additional formula and double angle formula inside. Okay. So we move on to the first question. Give you all some time to try and then you all can tell me your answers for question 1. Do you have any answers for part A? Okay, no problem. Means that you shouldn't find A equals to what, B equals to what. You shouldn't know what are these values. Mm, there are questions from, what do you mean? Yes, can. So did you manage to solve? Okay, no problem. I will go through also. Negative 0.01. I don't think so. Okay, wait. Let me go through. Okay, let me go through part A. So they say that A is an obtuse angle, which means that it is in the second quadrant, right? And B is acute, which means it's in the first quadrant. Okay, and then it tells us that sine A is 5/13 and sine B is 4/5. So we need to draw the triangles. So we know that A is in the second quadrant, so it's somewhere here. And then let's call alpha is basic angle. Then because sine is the opposite over the hypotenuse, right? So here is the opposite, 5, and then the hypotenuse is 13. So the adjacent is, by Pythagoras theorem, we know that is the square root of 13 squared plus minus 5 squared. And if you calculate that, that should give you 12. Okay, then for B is in the first quadrant, so it's somewhere over here. Then we have sine B is 4/5, so again opposite over hypotenuse. And then here we have square root of 5 square minus 4 square, which gives us 3. So here we need to make use of our addition formula, right? So tangent A minus B is tangent A minus tangent B divided by 1 plus tangent A times tangent B. Okay, so what is our value of tangent A? Here we look at this side. The tangent is opposite over adjacent. So opposite is here, adjacent is here. So 5/12 minus, here we have our opposite is here, adjacent is here, minus 4/3. Then we divided by 1 plus 5/12 times 4/3. So if you key that into the calculator, you should get wait, let me check. Oh wait, sorry, I made one mistake here. Here, because it's in the second quadrant, right? So the tangent, remember our ASTC? The tangent is negative in this quadrant.